Now let us move to the next question, that is question number 22. The angle of incidence for a ray of light at a refracting surface of prism is 45 degree. I is given to be how much? 45 degree for a prism. The angle of prism is 60 degree, A is 60 degree. If the ray suffers minimum deviation through the prism, the angle of minimum deviation and refractive index of the prism, of the material of the prism respectively are. So, you have to calculate two things, that is the angle of minimum deviation and the refractive index. So, this question came from the chapter optics, ray optics. So, how do you do this one? A bit of explanation is required. For minimum angle of deviation, it is twice of I minus A. So, 2 multiplied with 45 degree minus 60 degree. So, you will get 30 degree. 90 minus 60 is 30. Now, how much will be the refractive index for a minimum angle of deviation? Refractive index can be written as del m sine of del m plus A divided by 2 divided by sine A by 2. So, from here how much you will get? 30 plus 60, 90, that is sine 45 degree and sine of 30 degree, and sine 45 is how much? Root 1 by root 2, 1 by root 2, and this one is 1 by 2. So, your final answer would be root 2. Now, let us see in the option which one is the correct answer. If you look at the question, the right answer is option number 2, 30 degree and root 2. 30 degree is our minimum angle of deviation and root 2 is the refractive index. So, let us move to the next question, that is question number 23. When an alpha particle of mass m moving with velocity v bombard on a heavy nucleus of charge Ze, its distance of closest approach from the nucleus depends on mass s. That r will be dependent how it is, how the r will vary. So, you need to know the kinetic energy, which will be equated with kqq by r. So, how you are going to solve this question, that is important. This is a question from the chapter atoms. So, you need to use a concept of distance of closest approach, how you are going to do it. So, let me go to the screen. We know that kinetic energy is equals to k q into q divided by r. So, kinetic energy is half mv square. If you put the value of q for suppose what you have given, alpha particle, so it will be twice of E, and for the electron it will be Z E divided by R. So, if you look at this one carefully, this mass m varies inversely with what? The distance r. So, in the question, how the distance of closest approach will vary, they are asking. So, this r will vary inversely, that means r is inversely proportional to m, right. So, it varies inversely proportional with the mass. So, option number 1 is the correct answer. So, if you look at the option, you will find that number 1 is written as 1 by m. So, inversely proportional to mass m. So, this is your right answer. Now, let us move to the next question, that is 24. A particle of mass 10 g moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. What is the magnitude of the acceleration if the kinetic energy of the particle becomes equal to 8 into 10 to the power minus 4 joule by the end of the second revolution after the beginning of the motion? So, this is a question where you have to analyze it nicely, and you have to see, you need to calculate what? Kinetic energy is given to you, you need to calculate its acceleration. So, by a formula you need to calculate this one. So, the formula goes this way: kinetic energy can be written as half mv square w square. So, if you use this formula, you will see that your final answer is coming out to be option number 1, that is 0.1 meter per second square, right. Now, let us move to the next question, that is question number 25. The molecule of a given mass of a gas have RMS velocity of 200 meter per second at 27 degrees Celsius and 1.0 into 10 to the power 5 Newton per meter square pressure. When the temperature and the pressure of the gas are respectively 127 degrees Celsius and 0.05 into 10 to the power 5 Newton per meter square, the RMS velocity of the molecules in meter per second is. So how do you do this one? This is a question came from kinetic theory of gases. So you need to know the basic formula for velocity and temperature, how they varies with each other. Okay, now suppose for at the beginning for velocity v1, I can take this one as v is equals to, we know, root over of 3kt by m. So velocity is directly proportional to root over of t. So v1 will be directly proportional to root over of t1, v2 will be directly proportional to root over of t2. Now if I take v1 by v2, that will be root over of t1 divided by root over of t2. v1 is given to us, t1 is given to us. T1 is saying it's 27 degrees Celsius, that means how much Kelvin? 273, right, plus 27, that will be 300 Kelvin, and then 127 plus 273 will be 400 Kelvin. So this one will be 300 by root over of 400, which will be equal to, in place of v1 you can put the velocity, which is 200 meter per second and divided by v2. Now if you calculate v2, your final answer would be number 2, that is 400 divided by root over of 3. This is the correct answer for this question. Now let us move to the next question, that is question number 26. A long straight wire of radius a carries a steady current I. The current is uniformly distributed over its cross section. The ratio of magnetic field B and B dash at radial distance a by 2 and 2a respectively from the axis of the wire is. So here you need to calculate the ratio of the magnetic field, okay, at a radial distance a by 2 and twice a. So you first calculate for B and then calculate for B dash. In this question you are going to use the concept of the chapter called magnetic effects of current, and the topic which we will be using is Ampere circuital law. So now if you use this concept of Ampere circuital law, your formula will show as close integral of B dot dl is equals to how much? Mu naught times the current enclosed, right, I enclosed. So if you use this formula, your answer on the ratio will come out to be 3, but you have to use it differently for B at first and B dash again. So use this and you will see that your answer will be 1:1. This is the correct answer. So now let us move to the next question, that is question number 27. A particle moves so that its position vector is given by r is equals to cos omega t lambda naught. The position vector is given by r vector is equals to cos omega t x cap plus sin omega t y cap, where x cap and y cap are the unit vectors, where omega is a constant. Which of the following is true? You need to calculate what? You need to see there which one is the correct option. Here every option you will see that there are velocity and acceleration, right? Velocity is also there, acceleration is also there. So from the position vector you have to calculate first the velocity and then you have to calculate the acceleration. How you are going to calculate the velocity? If you know the position vector, you can easily calculate the velocity. The rate of change of position vector, how you are going to find out? You are going to do velocity as dr by dt. This is at first, and once you calculate this one, you need to calculate acceleration as dv by dt. So at first you need to know what is r. You just put the value of r here and then differentiate with respect to time, and whatever you will get here you will just put it in place of this one and differentiate with respect to time. So acceleration you will be found out. You will see that option number 3 is the correct answer. Velocity is perpendicular to the position vector, and acceleration is directed towards the origin. So number 3 is your correct option. Now let us move to the next question, that is question number 28. Now question number 28 says that what is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop. If you see the options, these are root over of gr, and then root over of 2gr, then root over of 3gr, and root over of 5gr. So which one will be the minimum velocity? Obviously root over of 5gr. This will give you the minimum value. So if you need to click the correct answer, it will be option number 4. Now let us move to the next question, that is question number 29. When a metal surface is illuminated with radiation of wavelength lambda, the stopping potential is V. If the same surface is illuminated with radiation of wavelength twice lambda, the stopping potential is V by 4. The threshold wavelength for the metallic surface is. This is a question, it came from the chapter dual nature of radiation and matter, where you have to use the concept of Einstein photoelectric equation, right? So what was the equation? We know kinetic energy is equals to h mu minus h mu naught, where mu naught is the threshold frequency, mu is the frequency given. So we need to change kinetic energy. We can write kinetic energy as ev naught also, which is equals to h mu minus h mu naught. So see the cases. At first it is saying that the stopping potential is V only for a particular metal surface. So this one will be EV, which will be equals to h mu minus h mu naught. Put it equation number 1. And in the second case it is saying that for a same surface, if the radiation of wavelength is twice lambda, the stopping potential is V by 4. The threshold wavelength for the metal surfaces. Now this one will be, in place of stopping potential, it will be V by 4. This one will be 4, which will be equal to h mu. I can write down c by lambda. Here it will be twice of lambda minus hc by lambda naught. So here you see, you can write this one as hc by lambda also. Frequency is equal to c by lambda. So if you equate, or if you take the ratio of these two equation, your final answer would be 3 lambda. So please keep the concept and do this one. Now let us move to the next question, that is question number 30. Question number 30, it says that a gas is compressed isothermally to half its initial volume. The same gas is compressed separately through an adiabatic process until its volume is again reduced to half. Then what will be its condition? So there are 4 options. Let me draw the PV diagram first for this one. This is a question came from the chapter thermodynamics. So if I draw a graph, this side is volume, this side is pressure. So volume, suppose finally it was V and it was reduced to V by 2, and initially it was reduced isothermally. So this is isothermally, and then it was reduced adiabatically to V by. So it is seen from the equation that compressing the gas through adiabatic process, you need more work done, right? So if you see the option from this PV diagram, the right option will be compressing the gas isothermally will require more or no. Compressing the gas through adiabatic process will require more work done. Number 2 is the correct answer. Compressing the gas isothermally or adiabatically, no. Which of the case, whether compression through isothermal or through adiabatic process requires more work done, depend upon the atomicity of the gas? No, this is not the correct answer. So option 2 is the only correct answer for this question. Now let us move to the next question, that is question number 31. Number 31, a potentiometer wire is 100 centimeter long and a constant potential difference is maintained across it. 2 cells are connected in series, first to support one another and then in opposite direction. The balance point are obtained at 50 centimeter and 10 centimeter from the position and from the positive end of the wire in the two cases the ratio of EMF is. Okay. Now here you have to calculate the ratio of the EMF. Fine. So it's like okay. So you have to use the formula from the chapter current, electricity, and the topic is potentiometer. Fine. So if you solve this one, that is the formula goes E1 by E2 is equals to L1 by L2. This formula you can use. So your final answer will be 3:2. Fine. Now let us move to the next question, that is question number 32. A astronomical telescope has objective and eyepiece of focal length 40 centimeter and 4 centimeter. To view an object 200 centimeter away from the distance, the lens must be separated by a distance. So this is a question from the chapter ray optics and from the topic optical instruments. So if you see there, you will find its formula. So what you have to do out here is, so you are given two lenses, one is objective, the other one is eyepiece. And we know in case of ray optics, in case of telescope, the objective has got higher focal length than that of eyepiece. And an object is kept at a distance of 200 centimeter. Suppose this is my object, fine, and it has got 40 centimeter focal length and it has got 4 centimeter focal length. You need to calculate this distance. Okay, at what distance it should be kept, this lens should be kept between each other so that the image is formed as 200 centimeter. So simply you can use the formula L is equals to Fe plus Ve. So the final image, if you see, you will formed at 50 centimeter. Therefore, if you find out the length, L is the length of the telescope, it will be 54 centimeter. So 54 centimeter is the correct answer. Now you search in the option. So number 4 is the correct answer. Now let us move to the next question, that is question number 33. Two non-mixing liquids of densities rho and n rho n greater than 1 are put in a container. The height of each liquid is h. A solid cylinder of length L and density D is put in this container. The cylinder floats with its axis vertical and length PL, where P is less than 1 in the denser liquid. The density D is equal to, fine. So you need to calculate the density D which is put into the container. Okay, that is a solid cylinder of length L. So how do you do this one? For that you need to show it diagrammatically. I will show the diagram, you see it and you try to find the answer. These two are at height h of the same height. Now what I will do, I will put a container out here. This is the container or the cylindrical rod. So this length would be 1 minus P multiplied with the L, and this length or this portion will be P L. Now if you know this diagram, what you can see that your final answer D would be 1 plus n minus 1 P multiplied with the rho, which is equals to your D. This is the correct answer. Now in the option we will see which one lies in the correct answer. So option number 4 is the correct answer from this question. So this is the right answer.
So question number 61 is on your screen. Two electrons occupying the same orbital are distinguished by. So this question is come from your structure of atom of your class 11 NCERT. So now we are moving to the solution part.